We're going to look at changing the subject of the formula today, guys. And to change the subject of the formula, the method that I like to use is transposition, right? So transposition, and you would have heard me use this term before, transposing a term from one side of the equation to the other side of the equation. It means basically moving a term from one side of the equal sign or one side of the equation. Right? Oh gosh, I wrote that horribly. Yeah, moving a term from one side of the equation. So let's say the left-hand side of the equation, right, to the right-hand side of the equation. So transposition deals with moving a term from one side of the equation to the next. All right. And what you need to know about transposition is when you move a term from one side, you do the opposite of the operation, right? So for example, if I had plus 5 on the left-hand side of the equation, when I move that across to the right-hand side, so when I transpose plus 5, it will become minus 5, right? If I were to transpose minus 5 to the other side of the equation, it would become plus 5. Right? And similarly, there are two other operations that we're going to look at. Well, actually, more than two. Well, it's not that there's more than two operations, but situations, I should say. Multiplication, which is another operation, when you move multiplication from one side of the equation to the other side, it will become divide because you do the inverse or the opposite of the operation, and the opposite of multiplication is division. So if I multiply it by 5 on one side, when I move it to the other side, it becomes divide by 5 and vice versa, right? So all of these are basically vice versa, right? So if you move plus 5, it becomes negative 5. If you move negative 5, it becomes plus 5. If you move multiply by 5, it becomes divide by 5. If you move divide by 5, it becomes multiply by 5. And we'll look at it in like questions afterwards, right? Another thing is to the opposite of the square root is to square something, right? So the opposite of taking, let's say the square root of x, the opposite of that would be squaring x, right? That's the opposite of squaring, and vice versa. The opposite of squaring is taking the square roots. All right. So those are some things that I want you guys to make a mental note of, or even a physical note if you're writing down right now. Um, that transposition involves moving a term from one side of the equation to the other side. And when you move a term from one side of the equation to the other side of the equation, you do the opposite of the operation. This is the whole premise upon which changing the subjects of the formula is based. Well, at least for me, you can use any method. Like, for example, when you're solving an equation, some people use the balancing method. So they do the same thing on both sides of the equation to get what x is equal to. I like to move terms from one side to the other side. All right, so let's look at some simple examples. Right, so let's say I had a plus B is equal to C. Well, even before we use letters alone, let's say I had to solve the equation, because when you are solving an equation, ideally, essentially, that's you are changing the subject of the formula. So for example, if I had x plus 3 is equal to 5, right? To solve for x, essentially, I want to make x the subject of this equation, which means I want x being equal to something, right? So I want to get x alone, but I want to get x by itself on one side of the equation being equal to something. And to solve this, I would say, well, this would just be x, and I want x by himself, so I'm going to move plus 3 to the other side of the equation. And when you move a term from one side of the equation to the other side, you do the opposite of the operation. So plus 3 will actually become minus 3. and therefore x is equal to 5 minus 3, which makes x equal to 2. And I could tell that that is correct because if x represents some unknown quantity, and when you add x to that, when you add 3 to it, you get 5. Well, the only number that you can add 3 to give you 5 will be 2. So x must be 2. Now, if I had x plus 3 is equal to y, the same steps would apply. If I want to solve for x or I want to make x the subject, well, this would be x is equal to y take away 3, because I'll move the plus 3 to the other side of the equation. It becomes minus 3. And here in this equation here, x is the subject. The subject of the equation is whatever, like if it's x or a or whatever, it's the coefficient of it is 1. So 1a is equal to something, 1x is equal to something, right? Notice it's not minus x, it's positive 1x is equal to y minus 3. And x here represents, we don't know in this equation because we don't know what y is. In the first equation, we could tell that x is 2, right? So x here is the subject. Now, if I had, for example, like if I had 2x minus 5 is equal to 11, right? By algebra, to solve for x, I'll have to undo everything that's happening here, right? Or because we're changing the subject of the formula, I'm going to say make x the subject here. To make x the subject, what I'm trying to show you is the same as solving for x, right? So the first thing you would get rid of is the minus 5, or I shouldn't say get rid of, but I would transpose minus 5 from the left-hand side to the right-hand side because I want x by itself. So moving minus 5 to the other side is getting me one step closer to getting x by itself. So I'll just end up with 2x on the left-hand side is equal to 11. And well, since this is minus 5, when I transpose that to the other side, it becomes plus 5. So I have 2x is equal to 11 plus 5, which means that 2x is equal to 16. And then 2x is equal to 16. Well, 2x literally means 2 times x. And the opposite of multiplication is division. So if I want x by itself, I've got to transpose this 2 to the other side, which means I'll have to divide by it because on the left-hand side, it is being multiplied. So x is equal to 16 divided by 2, which makes x equal to 8. Right? So here we could have solved the equations in that we could get what value x is equal to in this example here, example 1 and example 3. Right? In example 2, we couldn't solve for x because there's another variable y in that equation. However, I could get an expression for what x is equal to, and x is equal to y minus 3. So in the event that I find out what y is, I could figure out what x is. Because, for instance, if y is 9, then x would be 9 take away 3, which is 6. Right? So depending on whatever y is, I'll be able to determine what x is because I know the expression that x is equal to. Right? So changing the subject of the formula has to do with moving terms from one side of the equation to the other side of the equation so that you can just get that single term that you're looking for, right? So Josh, you're with me so far?
Yes, please.
Is it making sense so far?
Yes, please.
All right, so let's look at all of these had numbers and we could have solved them. And the purpose of that, like I said before, was just to show you that changing the subject of the formula is exactly like solving an equation, right? So if we have A is equal to B plus C, right? In this equation here, right, A is the subject. right? So A is the subject here because A is equal to an expression, which is B plus C. So A is the subject here. Now, if I wanted B to be the subject, I would need B to be equal to something to do with A and C, right? So if I have A is equal to B plus C, and I want to make B the subject of the formula, well, I would need B by itself on that side of the equation. So I would need to move C to the other side. Now you have to pay attention to the operation that is being done to C. You don't just move C all willy-nilly, right? C is being added here, and the opposite of addition is subtraction. So B is therefore equal to A take away C, because since this is plus C, when I transpose that plus C to the other side of the equation, it becomes minus C. And here I have A minus C is equal to B. Now, this here, B is the subject of the formula because B is they're giving us an expression that B is equal to, but it's just customary to write it on the left-hand side. So it's customary to write it like this instead. B is equal to A minus C. I have not changed anything. I just wrote B on the left-hand side instead and A minus C on the right-hand side, just because we customarily write when we're writing the subject of the formula, we write it like that, right? Where the thing that the term that you're trying to make the subject, we would typically put it on the left-hand side. So you could work it out on the right-hand side if you want, like how I did it here, but then write your answer as this, where the subject is the term, right? On the left-hand side. So here, B is the subject. B is the subject, right? B is the subject because we have an expression for what B is equal to. And likewise, if I wanted to make C the subject of the formula, well, B plus C is the same as C plus B, right? So I want to move B to the other side of the equation, and on the right-hand side, B is being added. So I will do the opposite of addition, which is subtraction. So A minus B is equal to C. Therefore, the subject of the formula, when C is the subject of the formula, the expression would be equal to A minus B. So here, C is the subject. So to make a term the subject of the formula, when you have addition being done, to move those terms from one side of the equation to the other side, you do the opposite, right? So, Soraya, is this okay so far? Are you following with me, love?
Yes, miss.
Okay, so help me, Soraya, with 1. Okay, so let's say I have P is equal to S plus R, and I want to make S the subject. What would I do here to make S the subject?
Make S the subject and move R.
Good. And what would it become then? It would be P what? Plus or minus R?
P minus R equals S.
That's right. It'll be P minus R is equal to S. So therefore, S is equal. I'm just writing it over, right? Just in the customary way. So S is equal to P minus R. Great. Thank you, Soraya. Matt,
Yeah, miss.
what about if I had X is equal to 3 plus Y, and I wanted to make Y the subject?
Um, you do y equals to x minus 2.
That's correct, because I'll move 3 to the other side, so it'll become X minus 3 is equal to Y, and then just writing this over, Y is equal to X minus 3. Excellent. Matt? Not Matt, sorry, Josh. Josh?
Yes, please.
What about if I have A is equal to B minus C, and I want to make B the subject?
It will be A plus C equals
That's
B.
right. That's right. So here, B is the subject. B is equal to A plus C. Excellent. I wonder if Faith, you could participate as yet? I doubt. I doubt she could. All right, so we're going back to you, Soraya.
Okay.
Ready? Okay. What about if I have R is equal to S plus 2T, and I want to make S the subject?
Uh, you would move you'd move the three, not three, the two.
The whole thing, because this whole term is 2T. Yeah? So then it would become what? What would be the next line?
Next, that would be R
Mm-hmm.
equals
Well, remember, I want
2T.
S, right? So I want S by itself. So I have to move
So
2T.
R
Mhm.
minus 2T.
That's right. That's the answer, right? So S is equal to R take away 2T. Thank you, Soraya. Matt, what about if I had V is equal to U plus 10T, and I want to make U the subject?
Which subject?
U. I'm writing the one that I'm making the subject in brackets
V,
next
t-
to the
V,
question.
V take away 10 equals to U.
V take away 10T.
Yeah, miss. Oh, it's 10 to? Yeah,
Yeah,
miss.
10T. Yeah, great. Right? So V take away 10T is equal to U. So therefore, U is equal to V take away 10T. Right? Josh, what about if I had N is equal to P take away 5Q, and I want to make P the subject?
It will be N minus P.
I want to make
Is
P the
it,
subject.
oh, sorry, what, plus 5Q.
That's right. N plus 5Q would be P. So if P is the subject, it will be P is equal to N plus 5Q. Now, 5Q plus N is the same as N plus 5Q, right? Because addition is commutative. So the order does not matter. All right. Now, just to recap quickly, let's say I had x is equal to 2y, right? And I want to make y the subject. Guys, this 2y literally means 2 times y, right? This means 2 times or 2 multiplied by y. So if I want to get rid of the 2, because I want y, right? I don't want 2y, I want y by itself. So if I want y by itself, I'll have to do the opposite of times and by 2, which is dividing by 2. So therefore, x divided by 2 is equal to y. So if y is the subject, it will mean y is equal to x over 2. All right. So, and that is like any question, any algebraic question that you did where you end up with, for example, if you had 2y is equal to 10, well, you would tell me that y is equal to 10 divided by 2. Y is equal to 5, right? It's the same thing here, except I have x over 2. And I cannot simplify even further because I don't know what value x stands for, right? So when you have multiplication, so when you have a coefficient, right, to get rid of the coefficient in any term with a variable, you divide by that coefficient. So if I had 3y, to get rid of it, I'll divide by 3. If I had negative 6a, to get rid of the negative 6, I would divide by negative 6. So to get rid of a coefficient, I'm going to write that down, right? To remove, I should say, a coefficient, you divide by the coefficient, right? So to remove a coefficient, you divide by it, right? So for example, if I had, negative 6a, then a would be equal to, I should put the arrow, a would be equal to, well, negative 6a divided by negative 6, because look what would happen. The negative 6 will cancel, and you'll just end up with a, right? So to remove a coefficient, you divide by it. And then if you had like negative 6a is equal to b, right? Then a would be equal to b divided by negative 6. So you divide both sides by negative 6 if you may, right? If you want to think of it that way. But to get rid of a coefficient, you divide by it. So given that piece of information, Josh, how would I solve, what if I had C is equal, no, 3C is equal to F, and I want to make C the subject? What would it be?
It will be F, what, F over 3.
Correct. So C would be equal to F divided by 3. Excellent, right? So guys, to get rid of a coefficient, you divide by it. So look at this interesting one, right? Let's say I had V is equal to 1/2 T, and I want to make T the subject. Well, it still remains, the fact still remains that I want to get rid of a half, right? Because I only want T. So it still remains that I would divide by a half. So I'll say V divided by a half is equal to T. Now, if you recall, when you are dividing a fraction, the division changes to multiplication, and the fraction, the second one, is inverted, so it's flipped. So dividing by a half is the same as multiplying by 2 over 1. So this would actually give me, well, this would be equal to T, and this would actually give me V times 2, which is 2V, and 1 times 1 is 1. So it'll be 2V over 1 is equal to T. So therefore, T is equal to 2V. And that's how you would make T the subject. So it's still the same rule in that you are dividing you're dividing throughout by the fraction 1/2. But what you have to recall is when you divide by a fraction, you flip the fraction and multiply, right? So another way that people think about removing a coefficient that is a fraction is multiplying by the reciprocal. Right? So dividing by a fraction is the same as multiplying by its reciprocal, right? So like, for example, if I had 2/3 x is equal to y, and I want to make x the subject, then I would have to divide by 2/3. So I'll say y divided by 2/3. Now, saying y divided by 2/3 is the exact same as saying y times the reciprocal of 2/3, which is 3 over 2, right? So that would actually give me x is equal to y times 3, which is 3y, and then over 1 times 2, which is 2. So x is equal to 3y over 2. I'm going to do another one like this. Are you guys writing this down right now? Please let me know if you're writing it down right now or if you're just following and you're going to write it down after. Because of course, you know, I'm turning the pages, so just let me know, right? So let's say I had 5/7, right? So 5/7 m is equal to n. Right? So, and I want to make m the subject. Well, to make m the subject, I would have to divide by 5 over 7. So m is equal to n divided by 5 over 7. However, when you are dividing by a fraction, it actually is multiplying by the reciprocal. So it's 5 over 7. The reciprocal of 5 over 7 is 7 over 5. So you'll have n over 1 times 7 over 5. And that would give me n times 7, which is 7n, over 1 times 5, which is 5. And that would be your answer, 7n over 5. So to get rid of a fraction when it's the coefficient, you divide by it, but you have to recall this critical thing here, which is that when you divide by a fraction, you actually multiply by its reciprocal, right? So that is very important for questions like that. Okay, and then the next one is like if you had, let's say I had, what question is this? This is question 12. So say I had something like L is equal to M over K, and I want to make M the subject, right? Well, here, right, M over K, it literally means M. Well, M over K literally means M divided by K. And I want to get M alone on that side. So I'll have to do the opposite of dividing by K, which is multiplying by K. So this would end up becoming L times K, which is LK or KL. So LK would be equal to M. And that would be your answer. M is equal to LK. That is making M the subject, right? So this M over K literally means M divided by K. So if you want to get rid of the K, you would have to multiply by it because the opposite of division is multiplication. Okay, guys? Another way to look at this, and I really want you all to keep a mind, keep a note of this because it would help when you're solving fractional equations, is if you ever have something like L is equal to M over K. I think I showed you all this with the trigs. You put this over 1, right? So now you have fractions on both sides and you cross multiply. So you'll say that this will be 1 times M, which is what I'm trying to find anyway, M. And then this would be L times K, which is LK. So you see you get the same answer, same answer. So whenever you have fractions, you could cross multiply like that. So for instance, if I had, let's say I had A over B is equal to C, and I wanted to make A the subject, well, I could rewrite it as A over B is equal to C over 1. And then I cross multiply, so 1 times A is A, and B times C is BC. And here I have A as the subject. A is equal to BC. Right, guys? So let's I'm gonna pause the recording for a little bit and I'm going to give you all a little exercise. Right, so say we had V is equal to U plus 2T, right? And I want to make T the subject of the formula. Now, this is the same as if I had an equation. Let's say I had 15, right, is equal to 3 plus 2x. And I want to make x the subject, right? To solve for x, well, I would first have to minus 3. So I'll have 15 minus 3 is equal to 2x. And then that would be, well, 15 minus 3 is 12. And then to get x, I would have to divide by 2, right? So then x is equal to 6. Now, this is identical. This question, v is equal to u plus 2t, is identical to the steps that we did in solving for x on the right-hand side there, right? Except instead of 15 and 3, I have v and u. So when you're changing the subject of the formula, it's very important to identify what are the operations being done here. So in v is equal to u plus 2t, well, this is multiplying by 2, right? So this is multiply by 2, right? And then here is then adding. So the two operations are multiplying and adding. So that therefore means that when you are doing the opposite, it'll be the opposite of multiplication and the opposite of addition, right? Now, when you're changing the subject, the first thing you'll change the term, you'll move or transpose the term that doesn't involve the variable you're trying to find first. Just like when I was doing 15 is equal to 3 plus 2x, the first thing I got rid of was the 3 from on the right-hand side. In the same way, I want to get rid of the u, and this is adding u. So to get rid of adding u, or to transpose add u, I will subtract u. So it will be v minus u is equal to 2t, right? And now I'm very, very close because t, the only operation that's separating t from being by itself there is this multiplying by 2. So it's the opposite of multiplying by 2 would be dividing. So v minus u divided by 2 is equal to t, and therefore, if t is the subject, it will be equal to v take away u divided by 2. So the thing with transposition, guys, you just have to really analyze what operation is being done. V is equal to u plus 2t literally means that you first multiplied by 2, right? So you took t and you multiplied it by 2, and then you added u and you got v. So to undo that, you would have to do the opposite of those operations. So you're kind of working backwards, right? So to get v, you would have had to say 2 times t and then add u to that. But to get t by itself, you would have to minus the u and then divide by 2. All right, so let's look at another one. Let's say I had P is equal to 2s plus r, and I want to make s the subject. Well, to get P, I would have had to multiply s by 2 to give me 2s and then add r. So if I'm working in the opposite direction now, because I want to undo everything and get back to s, well, I would first have to minus this r. So it will be P take away r. That's going to give me 2s. And then, well, to get 2s, I would have had to multiply by 2. So in order to get rid of the 2, like you know, to get rid of a coefficient, you divide by that coefficient. So P minus r divided by 2 is equal to s. And here, s is the subject of the formula. So s is equal to P minus r over 2. All right, guys, let's do another one together. Josh, let's do one.
Miss.
So if I have v is equal to u minus 3t, and I want to make t the subject, what would I get rid of first, the u or the minus 3?
The u.
Yes. All right. Now this is adding. So when I move it to the other side, it becomes,
Addition.
no, it's adding right now. This minus has to do with 3t. not u.
So when you move when you replace u with v,
Not
um
replace it, you're transposing it, so you're moving u to the other side. So this will end up being v take away u, right? Because this u, the operation of this u here, the sign of u is plus, right? The sign of 3t is minus. So if I'm moving plus u to the other side, it becomes minus u. And that's a very, very good point to raise there, Josh, right? Because many times students would look at this minus sign and think that that has to do with this u, but this minus sign has nothing to do with this u. This u, this part of this right-hand side of the equation is u take away 3t, and I could also write that as minus 3t plus u. So really and truly, the operation of u here, or the sign, I should say, the sign of u is positive. So when you move a positive term to the other side of the equation, it becomes negative. So this will end up as v take away u is equal to minus 3t. Just like if you had an algebra problem, that minus sign is now the sign of 3t. So the coefficient here, guys, I want you all to pay close attention to this. The coefficient of t is actually -3, right? So -3 is the coefficient of t. So not just 3, but -3. All right. And if I have to get rid of the coefficient, remember you have to divide by it. So on the left-hand side, I would say v minus u divided by -3 is equal to t. So the subject of the formula, if t is the subject of the formula, it would be equal to v minus u divided by -3. I want you all to write this one down because this particular instance, when you have a negative sign after a term, lots of times students mistake that sign to be the sign of the term. In this case, they may think that u is minus on the right-hand side, but that is not so. 3t is being minus. So that minus sign has to do with the 3t, not the u. All right. And if I'm moving u to the other side, I would have to minus it because the sign of u here is plus. When you move a term from one side of the equation to the other side, you do the opposite of the operation. A positive will become a negative. So u minus 3t is the same as saying minus 3t plus u. So if you add u, then to get rid of it, you would have to minus it. And you'll end up with v minus u is equal to -3t. So therefore, v minus u divided by -3 will give you t, since -3 is the coefficient of t. So I want you all to really, that is something that students mistake quite often. So I want you all to pay close attention to that. All right. The second Joshua. Let's do one together. Right, Josh?
Okay.
Okay. So, Josh, is your last name hyphenated? Like, is it Jupiter Yearwood, or is it just Yearwood, or just Jupiter?
Just Jupiter.
Okay. Where did I get? Why do I have Yearwood here? I have your name as Jupiter Yearwood. I have to fix that. Okay. Um, Hold on, let me get one. Right. So if I had R is equal to S plus 2t, Josh, and I want to make t the subject, what would I do first?
Um, it will it will be R minus 2.
No, it'll be r minus s. Because this is s plus 2t on this side, and I want to make t the subject. So first I have to get rid of this s. And this is plus s. So when I move s to the other side, it will be r minus s is equal to 2t. And then what? I'm trying to make t the subject.
And then you will put r minus s over 2.
That's right. I would divide by the coefficient of t, so I'll divide by 2. So t is the subject here. T is equal to r minus s divided by 2. Don't go away. Stay here with me. What about if I had, Soraya, I'm still waiting to get the questions from you, by the way. Please send it. What about if I had, A is equal to B plus 2C, and I want to make C the subject.
It will be a minus b
Mm-hmm.
equals to 2c.
Mm-hmm.
And then it will be a over b.
A over B? No.
Right. I mean a minus b
Uh-huh.
over 2
That's right.
is equals to c.
Correct. So C is equal to A minus B over 2. Great. Now if I had, let's say I had V is equal to 2 U plus 3W, right? And I want to make W the subject. Well, the first thing I will do is I'll have to minus this 2U. So it will be V take away 2U is equal to 3W. And then what? What else, guys? What will be the final answer to get W by itself? Anybody?
It will be b minus 2u over 3.
Correct. Right? So W is a subject when V minus 2U is divided by 3. Perfect. Okay, let's look at if we have C is equal to X minus Y over 3, and I want to make Y the subject. All right, so the first thing I'm going to do is I'm going to get rid of this X, right? So this is, remember, this minus sign has to do with y over 3, right? It is not included for x. This is really plus x. So when I move plus x to the other side, it becomes minus x. So I'll have z minus x is equal to minus y over 3. And then I want to get rid of the 3, right? So guys, what I will do is I'll multiply by 3 because this is y divided by 3. So to get rid of the 3, I would have to multiply by 3, which you have to multiply the whole thing by 3. So I'll just write it in brackets. I'll put z minus x in brackets. 3 times z minus x is equal to negative y. And remember, to make a term the subject, the coefficient has to be positive 1. So you don't want negative y, you want positive y. So to get rid of this negative, you could just divide throughout by the negative or multiply throughout by the negative, and that's how you would make it positive, right? So let's say, let's multiply throughout, but let's divide throughout, dividing throughout by negative 1 or multiplying throughout by negative 1 will give you the same result, right? However you want to do it. So divide throughout by negative 1. So that would be 3 times z minus x divided by -1, right? Because of course the coefficient of y here is -1. So if you divide throughout by -1, you get rid of that coefficient, since a negative divided by a negative is a positive. And this would be your answer. 3 times z minus y over -1. And this can also be written as, well, let's write y here since we want y as the subject. Y is equal to, now, if you divide this whole thing by -1, you'll end up with -3 times whatever. So -3 times z minus x. And that would be your answer. I want you all to copy that down. And let's take a break, guys. Let's take a little break because we've been going. Gonna pause record for a while. Yeah. If you use real numbers, if you had 2 squared is equal to y, right? Well, all right, 2 squared is equal to y. That would mean 2 squared is equal to 4, right? And 2 is equal to the square root of 4. So this follows the same principle where x here is 2, right? Because x is, well, x squared, so that'll be, x will be 2, and y is 4. So x is equal to the square root of y. So how that would look in questions, it would be like if you have, for instance, you have y is equal to 9x squared, and I want to make x the subject. Well, this would be, first I'll get rid of the 9, right? The coefficient of x squared by dividing by 9. So y divided by 9 is equal to x squared, and therefore x will be equal to the square root of y over 9. So that would be the answer. But you could even simplify this a step further by saying x is equal to the square root of, well, the square root of y over 9 is y, well, let me show you all. For this level, you all don't need to know this, so we'll leave it as that. But yeah, if you have to find the opposite of squaring is taking the square root. So just like how you would move do the opposite of addition as subtraction, the opposite of squaring is square root. And similarly, if you had, let's say you had m is equal to the square root of n over 3, and I want to get, or let's say 3n instead, the square root of 3n, and I want to make n the subject. Well, the opposite of square root is squaring. So this would be m squared is equal to 3n. Right? And if m squared is equal to 3n, remember, to get rid of the coefficient, you divide by the coefficient. So m squared divided by 3 is equal to n. All right. Guys, we're gonna stop there for today because my throat just can't take it anymore. I'm going to send this recording as well as the notes